SC, or steel concrete composite, is a form of construction made of two steel plates with shear studs and a concrete infill between the plates. It can be used to construct panels which, when joined together, form complete modules. SC construction offers many advantages over conventional reinforced concrete, including no temporary formwork, faster construction, greater strength and stiffness. And in industrial applications, electrical and mechanical equipment can be supported on SC structures without having to install embedded plates or concrete expansion anchors. During transportation, lifting and concrete pouring, the two plates must be connected together to form a self-supporting unit. To achieve this, bars, ribs or trusses, bolted or welded to both plates, have been used in the past. However, welding between the plates is manual and raises issues of health and safety due to the confined space. The steel brick concept was developed by Modular walling systems. It is a new generation of SC construction with an integral connection between the two plates. The first step in the manufacturing process is a regular pattern of semicircular cuts separated by straight cuts in a flat steel plate. The resulting strips are brake pressed into right-angled L-shape elements. Shear studs are welded to the solid leg of the element. A steel brick is made by welding two L-shaped parts to form a U-shaped element. The pattern cut into the plates creates circular holes in the base of the U to allow concrete to flow between steel bricks when the panels are concreted. Modules are manufactured by welding steel bricks together using automated submerged arc welding. Base plates and details for wall-to-floor and wall-to-wall connections are installed in the fabrication shop, leaving the simplest connections to be made on site. In the case of floors, the steel bricks have holes in both the base of the U and in one of the sides, so that the floor can have a concrete finish by allowing the concrete to rise above the plate. To test the buildability of the steel brick system, a full-scale construction trial was carried out. The structure chosen is part of a building which houses diesel generators used to provide electricity on nuclear power generation sites in the event that other means of electrical power supply fail. It was constructed at full scale out of 18 modules. The maximum module size was dictated by road transport restrictions. Joints between wall modules were detailed to explore a broad range of externally and internally bolted connections, welded connections, and complex joints combining bolting and welding. Bolted floor-to-wall joint details with simple and moment connections were also investigated. This enabled the quickest and most versatile side joining details to be identified. The structure was built on a reinforced concrete strip footing. Connection between the wall modules and the foundations was by holding down bolts. All modules were easy to lift and place at their position in the structure and fitted together well. Both manual and robotic side welding were investigated. This demonstrated that robotic welding resulted in a significant reduction in time to complete a joint. The structure was partially concreted using a highly flowable concrete mix. Following curing, removal of formwork at the wall ends revealed a concrete surface with no voids or defects. The project has enabled an innovative concept to be developed into a new construction product. We now have the confidence that steel bricks can be used for faster construction of core walls in buildings, retaining walls, and for industrial structures such as in nuclear power plant and small modular reactor buildings.